that so far. Is that kind of helpful? I hope this will prove to be helpful moving forward, particularly when it comes to these Excel examples that we will be doing. So I'm really think that this is very useful knowledge on how to do some simple Excel functions, and unfortunately it's sometimes a little challenging because you have different levels of understanding of Excel and IT, and I understand all of this. So we're going to do always practices and examples in Excel as well as in R down the road. And I have designated on the syllabus, you see designated days where we're just doing exactly that. So we have these lab days. They actually serve to kind of take a little bit the shyness towards Excel from you, and also help you to get a little bit of a head start with R. So I was actually hoping that we could do a little bit of R today, but as I've seen with my time management with the other class, likely we will not get to it today. But doesn't matter. So we're gonna get slowly more and more into data analytics, how to analyze data and data statistics. So we are now on chapter 2 with frequency distributions. And essentially, when you think of data, you remember from the Stroop test, we had different data types. We had a nominal variable, we had ordinal variable, we talked about ratio data, we talked about interval data. And so now there are ways, and there are ways needed to kind of make this data easier interpretable and digestible, right? If you have 20 entries, it's very hard to understand what that actually all means and what you can interpret in this data. We did last time, we did build averages and we compared averages from congruent versus not congruent. And today we're going to go a little different, a different pathway. Today we talk about frequency tables. Frequency tables, grouped frequency tables, and frequency histograms. So this is just very important because particularly when thinking of categorical data, where you have nominal data and ordinal data, you want to understand the frequency with which each of these possible values occurs. And for that very reason, a frequency table will allow you to get an overview. And for this very reason, you develop these frequency tables. Grouped frequency tables are basically nothing else but amalgamating them even further and just give you less granularity and get you, how to say, it's like one is like looking at it was a magnifying glass or with a loop, and the other one is like looking at it in a more holistic fashion. Frequency histograms is basically a way to depict those frequencies, where you depict the count for each possible value over the entire range of the value. And we will see histograms later on, and we will build one actually today, where we basically get an idea of how to characterize data visually. And I'm just flagging this because histograms, this is probably one of the most useful ways of looking at raw data that you could think of. It's probably one of the most often produced graphs in statistics, because it gives you an understanding of the data, it gives you an overview of the outlines. It shows you the shape of the distribution, which we will talk later on. So it's a very useful depiction of data. So, but now looking at frequency distribution as a definition. So frequency distribution describes a pattern of a set of values or a set of numbers by displaying the count or the respective proportion of that individual value. So when you have, for example, different nominal categories, you basically depict the count for these categories as a function of the respective possible value, possible category. The same if you have different numbers, and you have, let's say, the temperature of cookies, and you map out the temperature from 20 to 30 degrees Celsius, which I know most of you probably are more comfortable with Fahrenheit. So if you have a different range of possible values for this temperature, you have one entry for each temperature, and you show for each of these values the frequency with which you counted those cookies out. So the frequency distribution describes this count as a function of the actual possible value for that variable. A raw score is an individual entry. So for the cookie example, that's like the temperature of each individual cookie. So when we go back to the Stroop test, we have congruent, incongruent. Each individual value is essentially a data point, and the time this individual has needed to state the color of the font will essentially be an individual entry. Bulking this together, if 3 people needed 10 seconds, you have a count of 3 in that frequency table or on that histogram. If you have 11, then it's, let's say 2 people have 11, you have 2 people as a count on the y-axis. So it's simple, it's relatively simple, but the computation of frequency tables, which is the source for this depiction of the frequency distribution, is not that straightforward. The frequency table is here basically a visual depiction of data, and it shows how many times each individual score occurred in your data set. So the values, basically the possible values the data set shows are listed in one column, and the count is listed in another.
That like a bar graph?
If you visually depict it as a graph, it looks very much like a bar graph. Yes, in essence, we can look at it at one. So the frequency table will. So the frequency table essentially. So a frequency table will essentially look like that, and we will depict one. Whereas a histogram is literally like a bar graph. So it's for each individual entry you have on the y-axis, you have the actual count. But it is like a bar graph, just as you said. So this being said, let's essentially work on constructing such a frequency table. And this is the example that Nolan and Heinzen showed for this for the first frequency table we're going to compute. And you essentially have on your canvas 2 files. One is the PowerPoint presentation lecture showing you. The second one is the Excel sheet that basically contains the names of different countries and the count of volcanoes. So when looking through this data set, you're going to find a couple of very interesting aspects. Like, for example, I didn't know that the United States had 81 volcanoes. That was absolute news to me. So it's kind of interesting to look at data like that. And there's plenty of data like that publicly available in case you're interested in those. I can actually share a couple of links with you. It's fascinating what people have amalgamated in spreadsheets for just simple analysis. Okay, so we have now 55 countries and their respective count of volcanoes. So now when we want to quantify this in the form and shape of the frequency table, we need 2 things. The first aspect of this frequency table will be the actual value that can possibly be found. So first you need to determine, okay, so what's the minimal entry, what's the maximal entry in my data set? And you're doing that by selecting column A and B, clicking on data. So this is the tab data. And you go and sort. You remember how we sorted last time? We're just doing the same thing. So we're selecting my list has headers on the right top. We're sorting it by the column count. We're sorting it on values. And we're sorting it smallest to largest. Yeah. Click OK now. All our data is resorted with the country with the highest number of volcanoes being the last. That's the US and Russia, and Indonesia, and Japan. And the one with the least countries with the lowest alphabet. This is done alphabetical order, and Arctica was 1, Argentina was 1. This will be at the beginning. So we want to collect all this information. We want to put it in a frequency table. This frequency table will look like this. So we have the possible values, and we will have the count or the frequency. Let's call it frequency. So now the possible values we see now here is entered by the min and max. So this goes from 1 to 81. For the sake of simplicity, let's stop at 17. Let's only take 17 as the maximum entry, because otherwise it's just, yeah, it's easier to do this in that fashion. So we have now values 1, 2, and 3. And as we have done last time, we can build this series, and we can now complete the series by just going to the right lower corner of that selection of 1, 2, 3. We go all the way down, then we get to 17, and we're just completing the series. Okay? Relatively simple. So now we have a list of 1 to 17. Yes?
When I did that, it just continued one thing.
So you have 1, 2, 3. 1, 2, 3. And now you go in the right lower corner. You start pulling it a little further down. It should essentially continue the series. It should make a little 17 under your cursor. Yeah, you see that? Yeah. Good. You can thereby complete this list. Once you have completed the list, you can do something which is quite, yeah. So you go, so you see there's the right lower corner where the cursor changes once you hover over it. You see that? It changes from a solid white to solid black. And then you can just pull it down. And by pulling it down, you complete the series. Okay? And this is important. Well, you can also manually type it. Right? We're lazy. We want to do this simpler. Good. So now you can do something quite manual and easy to get your first frequency. So you want to know now. So we have the values. These are the possible values from 1 to 17. You want to know now how often did we see that 1? And this is 1, 2, 3, 14. It's 14 ones that we have in our data. Good. So we can just write 14. So now we want to know how often we have a 2. So now we could do it again manually, but there's an easier way to do that. And this is done with the so-called count function. So we have a function, yes.
Sorry, do you mind just reviewing how you get that like that list of values?
Well, you're just counting them. So if you, so you want all entries with 1. You have sorted them from 1 to 81. And now you just want to count these 14 entries. No, these are the individual values. So the 17 is actually Papua New Guinea. So these are the possible values a variable can take on in our data set. And we're counting how often each individual value occurs. Yeah. So here with the frequency of 1, it's 14. With 2, it's here also quite a large number. So these are all the 2s. So now we could carry on to count them manually. But there's an easier way to do that, and this can be done by the count function. So more specifically, so the count function essentially will count each entry within a selection that you tell it to count. So if you do count B1 or B2 to B5, it will count as many entries as there are in B2 to B5. But these are just random values. So if you do on the right side, you write here discontinuous series. Essentially, you have here 6 rows occupied with this discontinuous data series. If you do now count of this discontinuous 6 cells, will only count those that have an actual entry. So this is count. But what we essentially want to use for this specific purpose is the COUNTIF function. So COUNTIF is a function that will only count cells with a valid entry that fulfill a certain criteria. So COUNTIF, the range, is now the range from B2, which is the first entry, all the way down to Papua New Guinea, which is B52, right? So that's the range which we want to scan for a certain number of entries of 2. Makes sense? If we're going back up now to our formula, so we have now count if parentheses B2 to B52, comma, and now we're getting to the criterion. And the criterion is 2. We want to ask Excel to count all 2s in our data series. When we do that, we get 12. It's simple, right? It's a relatively simple formula. But as you can imagine, if you have a data series of like 100 entries and you want to count each individual entries, each individual value, like this makes life much easier. So that's a very powerful function. So now you would need to repeat this exercise for 17 times or 50 more times. So as I said, we're lazy. We want to simplify this a little bit. And we're simplifying this by further simplifying our formula. So if we do, last time I spoke about hard coding and soft coding. So right now with this formula, we hard coded. We told it, okay, so this is the range, this is the criterion, do that. X is doing that for us. Now we want to do some soft coding to make our life a little easier. So this is done by equal COUNTIF, again, B2 to B2 to B52, comma, and the criterion is 3, right? That's the row we're interested in. But that value is also contained here in the neighboring cell. So we can now query it to the neighboring cell. So we say, okay, so now that criterion is actually in E4. Make sense? So now Excel will use this formula to essentially accept that range, B2 to B52. And it will go after the comma and search for a criterion. And that criterion I define as look at cell E4, take that as the criterion. That's what that function means. And if we're doing that, we get a count of 4 for countries containing 3 volcanoes. And if we look here, this is 4 countries. Yeah? Yeah, yes, okay.
I have like a little triangle of an exclamation point in it. So the formula we saw refers to a range that has additional numbers adjacent to it.
Okay.
I have no idea what to do with that.
Can you override it? You mean this triangle? Formula omits adjacent cells.
Yeah.
You can just ignore it. So this is, so Excel wants to help you. And Excel tells you there could be something wrong with your formula. Just double check it. So that's pretty much what that means. So it gives you then a couple of gives you a couple of potential ways how to remedy that with Excel's logic. But essentially, that formula that you have is correct because this is exactly what you want to do. So Excel has like their machine learning algorithms running in the back. They're like they observe your behavior and they're like, you may not want to do that. You may want to do that. So this is pretty much what that means.
So how do I put it down to all the numbers?
We're getting there. So you have
No, I'm saying I haven't gotten to 3 yet.
Oh, you have not done this yet?
No, on frequency.
Okay, the frequency. Yeah, the frequency is count if B2 to column B52, comma, and this is where you define it as E4. E4 contains the value 3. And you're basically using this as your criterion. Yeah? Yes.
I don't get how you more than one. Like, I got like you just said like E4, but what if I want to do frequency of 4 and like
Well, we're getting now slowly. So essentially, what the end result of that will be is a formula. So I'm trying to stepwise go with you towards a formula that you essentially just write here on the first entry, you double click it, and it goes all the way down. So that's the end product.
Correct. And then I press E4.
Yes, E4 is the criterion. Be careful that you
What's
distinguish
criterion?
between the range. The range is essentially this. The range is here on the left. So this is what you are comparing your criterion to. The criterion that you use to count the frequency of each individual entry. So the criterion is 3 for this example, right?
That's what I'm trying to.
Exactly. This is what you're trying to count in your data range, in your data set. Yeah? You can also do this manually as we have done with 1, but you can also tell Excel to count. Yeah? Yes. Well, because we're going to go a little further with that, we want to automatize things.
But accidentally to 3, you get the same thing.
Yes, exactly.
Oh, so this is so cool. Right.
You could do it by hand, yes, by all means. You could count it by hand, you could enter it by hand, but I want to go stepwise towards automatizing the entire process. So the end result is to enter one formula up here, double click it, and you have it for all 17 entries. I'm just going stepwise, slowly, that everybody plays along. Good. Okay, count if. So count if B2 to B52, and we are now defining the criterion as E4. So if we were to pull this formula down, you remember how we pulled formulas down? Yes.
Yeah, sorry. When I put that in, it just stays like that.
Well, then you put an equal sign. Okay, let's start again. Put an equal sign first. What happens now? Okay, let's delete this. Equal sign. Good. Now write count if. Is something opening up? There should be here such a menu. When you make now an opening parentheses. The second one. No, you don't. Okay, equal count if B2 colon B52, comma, whatever criterion you want to do in that row you're in. If you're on F4, you want to use E4 as the criterion. Whatever cell contains your information 3 in that regard. Okay? Did that work? No, not comma, colon. No, yeah, colon B52 comma, and then the criteria. So if you're in the row that contains the 3, refer to that cell. Whatever that cell is right next to your formula, take this as your criteria. Yeah. If you're on row 3, then it would be, and you want 2, then do E3, yeah, otherwise do E4. Yeah. So take the one right next to your formula. Okay, once you have done this, so B2, $B52. Now you want the adjacent cell, which is E4. You press enter, you get 4. Good. So now you remember from last time when we are dragging a formula down, it will shift with your actual formula. So if you're dragging this formula now down, it will shift. It will shift the criterion to 4, but it will also shift the range down. And that's a problem. So the end product of this exercise is essentially to have a formula that you can just pull down easily. So now we're doing that. So we're going now back in our formula on F4, and we're locking it in. As you remember from last time, you're doing this with a dollar sign. So again, $B, $2, $B, $52. This is how you're locking it in. You're locking your range here on the left. So if you're dragging your formula down now, it will not shift. It will not shift, but it will remain at the same range. And that's the beauty of things.
Why do you need to do that? Why do you need to lock it in?
Because otherwise it shifts. So this is the initial formula. This is the initial formula. If I click, if I drag this down, it will change the criteria, but it will also shift the range. So whatever you mean to count will be counted on a different shifted data range. And that is deleterious, terrible mistake if you do that, because that creates tremendous errors. So if you do $B, $2, colon, $B, $52, this is not happening, and then essentially you just have to go to the right lower corner and propagate your formula down. And you get your frequency table completed. And that's it, you're done. That's your frequency.
What's the dollar to?
It locks in the data range. So you have here 2 different cells. One is the beginning cell, that's the end cell, that's the range to which you're comparing the criterion. So you're counting everything in the criterion. And if you would shift it down, the entire range shifts, and locking it in with the dollar sign basically locks in that range. Okay?
You always need to put the dollar sign.
You need to put the dollar sign if you want to pull that formula down. Like this. If you want to do it individually for each entry, you can do that too. Easy, not a problem. It just takes approximately 20 times the time, or 18 times the time. So that's the idea, right? You want to simplify things. You want to make them easier. You can also drag this formula up then. And now you can essentially with the formula in line 1, and this is the end result. The end result is essentially a formula where you can just double click and it restores it in a second. No, you can just, so if you have that formula done, you can delete all the other ones. So now it's soft coded, right? Now I just need to go back to this completed formula. I just propagate it all the way down. It stands by itself. I can change now whatever I want to change, essentially easily with using this. This is the advantage of soft coding. Yes. Yeah, yeah, sure. Actually, wait. This is the formula. So E4, whatever row you add, if you're still on row 4, please press $P, $2, colon, $P, $52, comma, E4. or whatever row you like.
That's defining the what?
Hmm?
Like if you told us like define mix and then we would use that equation, what would you tell us to find that equation?
Well, whatever you want to find needs to be defined after the comma. Yeah. That's a look of skepticism right there. All right. Good. So again, keep in mind, count if needs two components. It needs the range, which you're counting it out, and it needs the criteria, which is after the count. And you can soft code it or hard code it. I don't discriminate. If you send me homework and you're hard coding, perfectly fine with me. If you have the time to hard code things, be my guest. But I'm just flagging it. I would want to see all the formula. So if you submit a homework which doesn't contain formula, you will lose points drastically.
Is this document something that we should make?
Which?
The document on Word.
The Word document that I made that in previous class. Yeah.
Okay.
Yeah, because so the problem I have is so I'm yeah, I have a hard time with the small screen, and you have a problem with the small screen. Right? So it's I try to kind of amplify it and make it more legible for you. So yeah, okay. So this is frequency table. So far, so good. Next, let's move on. So I hope everybody has the formula on bar. I will send you that spread. Yes.
So I already said I submit this to you. I want you to separately write out all the formulas if there is not one.
Well, you're not submitting anything. You don't need to submit it. So I will send you that spreadsheet essentially. So you will have it at your disposition. Watch out for announcement. So I want you to have all the spreadsheets that we're doing in class. You will just face a homework that essentially will ask you to do calculations. And I am still working on putting together the homework. It's going to be a brand new homework, new examples, so really fun examples. And I would want to see all the calculations in there. And if you submit it without calculations, you will lose points. That was my point.
It's not the same type of thing. Like
It is the same concept, yeah. I will not ask you to do anything in the homework, which we haven't done in class.
that we learned to do.
Yes. Yes, yes. But we're just getting started with the equations. So, okay, so this is this number of, okay, so this is the histogram. So, okay, frequency table. So this is basically Norton and Heinzen's layout of what we just did. So this is Norton and Heinzen's version of that. And this, they are doing an advanced, in addition to that, they're calculating now also percentages. So I hope, do you know how to calculate percentages? Simple, right? So essentially, if you want to calculate percentages, you need to understand what the overall number of countries is. In that particular example, you need to sum all the countries up. You need to know how many countries you have in total, which we know it's 51. So we do sum of F2 to F18 gives you 51 countries, right? Which we know already because it's B2 to B51, B2 to B52. So 52 minus the header row is 51. So now this is our whole number of countries. So these are all the countries. And now I want to calculate first the proportion of countries that contain one volcano, which is 14, based in reference to all the countries we have quantified, which is 51. So you do that, so you know if you have a cake, if you slice a cake in 8 slices, you have 1/8 for one slice, right? So 1/8 is 1 divided by 8. 1 is the whole. 1 divided by 8 is then 0.125, which is 12.5%. So a percentage is calculated with get slice, and our slice is here 14. So 51 is the whole. We need to insert here F2, which is 14 divided by the sum of all entries. Right? So we have 51, the sum of F2 to F18. These are all the countries. 14 is the part of it that we want to quantify as a proportion. Okay. We want to quantify. We know it's 51 countries, right? Yes. Let's walk through it arithmetically. So we have 14 countries, and we have 51 countries in the entire thing. So to get the proportion of that, you're calculating 14 divided by 51, right? 14 divided by the sum of all of these is 51. That's a proportion. So this is 27. So now you can make it a little bit easier by saying, okay, so this is F2, 14, divided by the sum, SUM gives you the sum of F2, F2 to F18. Right? Closing the parentheses, closes the formula. So 14 divided by 51. So now you want to make life again a little bit easier. The reference range, which shall not change, is now F2 to F18. So you're locking in F2 and F18, and you make it F2 divided by the sum of $F, $2, colon, $F, $18. Gets you a locked in range. So this will always be 51, no matter what you do with this formula, wherever you drag it or copy it, it will always be exactly that range. It will always be 51. What changes now, if you propagate this formula down, is your numerator, because the numerator will change now to the row it's in. And this comes back now to the previous skepticism about why do we need those dollar signs, because it will lock this in. No matter what the numerator will change into, they will always take the same denominator. Right?
So when you put dollar signs, where do you have to put them on?
Well, on this formula, you put them on the range of all the countries. So this is the denominator.
Only the range.
Only the range does not change. So you have numerator. Numerator is the frequency of the respective value, whereas the denominator is the number of all countries, which is always 51, which is the sum from here to here, which is just all the volcanoes count, or all the countries count. Okay? And now you complete this, and you have your proportions calculated. So now coming from a proportion to a percentage is easy, because now we just have to multiply it by 100, right? And I please would ask you to review this in probably high school books or wherever you may have this information. Proportions and percentages will essentially be your starting platform for probabilities, which will essentially come very soon your way. And that will be quite essential to this class. So just make sure that you're kind of solid on these concepts, please. Okay, so if I multiply just a value by 100, you just have to drag it all the way down. It multiplies each entry by 100. You have the percentages of each entry. So logically, if I sum this up now, this is 100, right? If I sum the proportions up, it becomes 1. Good. That's the sanity check to make sure that we did it correct. So we have now the percentages I personally dislike many decimers. For that very reason, we're gonna round. We do this with the round function. The only thing you have to do, you go before the G2 multiplied by 100, you add the round function. And the round function will ask you for a number here, and then for the number of digits behind the comma, after the comma, which 2 seems appropriate. At least it's intuitively, I would say this is sufficient. And now we just need to propagate this new formula all the way down, and here we go with that. Sure. All right. We have G2 multiplied by 100. This is your proportion multiplied by 100 to get you to percentage. Now we go before the G2, in front of the G2, we write round, and we open a parenthesis before the G2. We go after the 100, we write comma 2, and we press enter. Third line. I know it's a little small and it's hard to read. This is unfortunately the problem. Like usually it would be nice if this were. Yeah. Everybody on board with us? You mean down here? Like that? No, this, no. Good question. Good question. I understand. That is a very good question. No, it won't. H2 to H18. Huh. Slightly. But not dramatic. But it's now 99.999. So yes, obviously, if you introduce rounding, and that's one of the problems essentially, whenever you round, you have the quote unquote rounding error, which will consequently propagate. It's surprising it actually does. It shouldn't, because it shouldn't if I round this and I round this, because this is also not rounded. Round this. Oh, I just rounded. So when, yeah, because I rounded to 2 decimals, then this difference of 0.0001 disappears again. Okay, so this is the frequency table in a nutshell. So now let's go back to Nolan and Heinzen. I will post the frequency table. I will post a spreadsheet so you can review the formula in peace and okay, so we have now the frequencies, the percentages, and now we're getting to the last level. So basically, right now we're looking at the magnifying glass on each individual entry. You can kind of change that level of granularity by kind of looking at it a little bit more holistically. And you do that by creating a grouped frequency table. So essentially, grouped frequency table is nothing else but working these numbers together, creating groups of data points. And this is simple. You can do it in a more sophisticated way with count ifs, where you define more than one criterion. We're not going to do that. We're going to do groupings. We're going to do 1 to 5, 6 to 10, 11 to 15, and we're going to do 15, 16 to 20. And then we're basically, the only thing we need to do is we're summing up the entries of our frequency table. The sum is now frequency 1 to 5. We do equal sum from 6 to 10. Sum of 11 to 15. The sum of 16 and 17 hypothetically of everything following that. So we basically we have now this grouped frequency table that basically summarizes the data even further. So you basically have now 3 different levels of granularity with quite simple functions. So if you want to do this in a very fast way with this formula, you can collapse this very easily, and you can essentially build these tables within minutes if you have the right functions at hand. So it's very useful. So you will be dealing with data, you will be dealing with Excel. If you are doing that with the right functions, it will make your life much, much easier. I guarantee you that. Good. All right. So now back to lecture. We are now looking at grouped frequency, and now we're getting to the actual visual depiction. So the histogram was mentioned earlier. The histogram is nothing else but a visual depiction of these counts. It's basically a frequency table in the form of a bar graph. That's pretty much what it is. It's not strictly that. It's a little bit more refined than that. It's a little bit more complex than that, but it is probably the most often produced graph in statistics because it's just such a wonderful tool to understand your data, to characterize the data and to understand it. So this is how that histogram will look like. And we're gonna reproduce this now in our Excel spreadsheet. And we're doing that essentially by quantifying, we're selecting now B2 to B52. We're selecting all of these cells, and we're going, and I recommend you kind of try that out at home and play around with it a bit. So this will be part of the homework too. So you basically go on insert graph. After you select the B2 to B52, you go on insert graph, and there is histograms to be selected. This histogram essentially looks very much like our grouped frequency table. Not exactly, because they have different ranges. So we could change our ranges and do from 1 to 4. But essentially, you can have Excel do this for you. We can customize these ranges, but that's basically a simple histogram that you can show you. So this is how you build histograms in Excel.
Insert and then what?
Insert graphs. You're on Apple. So here you will have the bar chart symbol, and once you click on that, you will have histogram. It's right here. You see that? This look. Yeah. So once you select the B2 to B52, this is how you get to that. Okay, so these are histograms. Well, Northern Times clearly have a more beautiful histogram. To be honest, I think the only reason I ever did a histogram in Excel was to actually show this to my class. Otherwise, I would not do histograms in Excel. It's also, you do it in different softwares, you do it much more aesthetically appealing rather than Excel. Excel graphs are rather frowned upon. Good. So these are histograms, and you can group it. You can group it in different bins, so you can customize them. So there are various ways how you can approach your data. We can, not today, but so with bar graphs, you essentially can also show them in different versions. Good. So now, when thinking of this distribution, so this histogram basically shows you the so-called frequency distribution, because it shows you the frequency of each individual entry. Just like I said in the beginning, in definitions at the beginning, this is what the frequency distribution means to represent. So it's a distribution of individual scores and the occurrence, the count of each value's occurrence. So this is basically what you mean to characterize with histograms, and histograms also allow you to visually interpret and visually characterize your distribution. For that, you need certain terminology, which essentially you will distinguish between a normal distribution and skewed distribution. The normal distribution is essentially what you see on this graph. So the left, so a great distribution. So you basically you have a normal distribution here, where basically the mean, so central tendency, would basically be the highest point. We have a symmetric distribution on both sides of that central of that occurrence of that highest, the most frequently occurring. This is normal distribution. In most cases, this is not the case. In most cases, you rather have something like this, which is a so-called ceiling effect, where basically you have a ceiling to the top, to the higher values. The higher you get, the closest here, 4 is the highest GPA. So you basically, it closes to the right, and it's not a normal distribution. In a perfect world, you would have a normal distribution that really looks nicely characterized. It's characteristically bell-shaped, it's symmetric, and it's unimodal, which means it only has this one peak. You have situations where you have 2 of these, that's binary, but triangle with a multiple. Okay, so this is the normal distribution, and when it's not symmetric, you speak about skewed distributions. And so this is a little bit different. So when it's not symmetric, basically you speak about a positive and a negative, positive and a negatively skewed distribution, which basically means positively skewed is when the tail being this here, this is the tail. If the tail points to positive values, the higher values, is positively skewed. If it points to negative values, it's negatively skewed. This is important because this is what this mnemonic needs to characterize. The tail tells the tail. Please memorize it because you're going to see it on the quizzes. And that would be really, it would be pity to those points because something like that. So these are just definitions, and unfortunately, these definitions are a substantial part of statistics as well, because the way you communicate your data, or you describe your data to your audience, to a statistician or to anybody else, matters. Okay, so we talked about floor effects and ceiling effects. So we have here a floor effect, describes a so-called positive skew. Floor effect, typically what you see in this, so you think of data that distributes in that fashion. Does anybody have an idea what kind of data could show that, could present like that? Where you more likely have lower values and less likely higher values? Household income of the United States of America. Typically, when you see these census graphs, typically household income varies well. And then when you get to the higher levels, it goes slower because it's just less often occurring. There's a classic example. It's like one of the most exemplary examples for this purpose. Negative skew, thankfully, this is most often found in quiz grades and exam grades. So we would assume that a good class, easy quiz, will create a ceiling effect where basically all students have really good grades on a few outliers. I wish that all was like that. But yeah. Okay, so this is the skewness. Positive skewed points to positive values, negative skewed points to negative values. Dot plots, and this is the last topic we're going to discuss. So a dot plot is a graph, which is a rarity. I think I've seen like only a handful. If you really have a small sample size, you really have just little data, like in genetic, in the world of genetic testing, reporting, and genetic statistics, you find dot plots sometimes, but it's rather a rarity in my world at least. So it is a graph that shows actually every data point. What the histogram shows as a bar, dot plot will show as a point. So essentially that's how it looks like for the example that Nolan and Heinz are showing. So essentially you have a dot plot that depicts the years of education globally. Essentially you have for each of these years, and you only have 5 countries that have 13 years of education. And so you would essentially just place dots at every value for every score. So this is essentially how you would be approaching this. And this is pretty much all I had for today. And that's beautiful because now we get actually to a little bit of R. Okay, and my time management for the first class was really not good. So I'm posting now classes from both. I will point if there were differences. If you want to see something in addition, you always can. I cover the same material, but if you want to repeat something, I may have something earlier for you. So now if we open up our studio, you have on your canvas for module 3, you have here our code discussed in class. And this is when I was very optimistic and I thought I would be better with my time management. This is when I created it. Okay, so you have in our studio, you have 4 different quadrants. Here the so-called console, which is the core engine of the entire environment. You can, if you go on the left upper corner, there's a little pull-down menu where you can click on our script. The script is basically nothing else but your coding script. This is where you write your code. This is just moving ahead a little bit from lab data. More data from lab data and practice lab. So once you created this, you basically have 4 quadrants. So quadrant number 1 is the script. By opening our studio.
Yeah.
So did you open our studio and not R? Does yours look like that? No. Does it look like somewhat close? Maybe this is the distinction. So do you have this part? So let's close this. Do you have this part?
Yeah.
Do you have these 2 on the right? No? Are you in R or R studio? Okay, different is not necessarily a bad thing, but this is a good conversation to have. So you don't have here the environment on the right top. Just to make sure you're not on R, you say.
Yeah.
You're in R studio.
Yeah.
Not on R. So because this is an important distinction because there's also R and R looks like this. Don't go into R because this is so-called base R, which I started programming in base R. This is a little bit tougher because our studio made it a little bit easier to kind of work with. So if you have here these 3 quadrants for now, this is your console. So where the cursor is blinking, that's the console. That's actually R. Here you have on the right top, you have the so-called environment. And you have on the right bottom, you have packages, the plots, the help. So you have kind of like a depiction field where you depict various things. So if you go now on the right top corner, you have here a pull-down menu. If this opens up, you can click on our script, and that opens the script. A script is nothing else but a notepad where you basically write down your code, then you tell R to run it. So if I say now 1 + 1, and I press Control and Enter, R will run this for me. So it will calculate 1 + 1. Did that work? Yeah, simple, right? This is a good starting point. Okay, so we have now 1 plus 1. So now we want to make it more challenging. Now we do 1 plus 1 multiplied by 8, which is essentially now 9. So, yes. After the 1, this is 1 plus 1 multiplied by 8, yeah. It's just a random example, so don't interpret too much into it. Okay, what you can also do in R, which is something some of you may be familiar with, and I'm trying to zoom in a bit. I don't know to what extent you had some coding ever before, but in R you can assign values to so-called variables or objects. So you can say A equals, and the equal sign is depicted in a different way. It's basically it's a smaller sign and a hyphen. And you say A equals 1. Now, if I run this with control and enter, I basically get the value of 1 assigned to A. If I say now B, smaller sign hyphen, is 8, I assign 8 to B. So now I can rearrange my equation from up here to A plus A multiplied by B. This will also be 9. Yes. You should run this.
Yeah.
If you run it with control enter. If you do control and enter, it will run each line in which you press control and enter. And that should fill up your environment. So what this means is an object is in the easiest format, it is a so-called vector. So this is essentially just a vector of 1, but I can also make it longer. I can say AB equals, and you need to let it know that you have more than one entry. So you do this with C parentheses. It's concatenate. You do 1, 2, 3, 4, 5, 6, 7, 8, 9. So now my AB has now numerically 1 to 9, 9 entries. So now when I call AB, it will again show me the 1. But here this 1 refers to the first chunk of the data. So if it's more values, it will give you here 1, then the 2, then the 3. So it gives you for each line. And this is just for you to determine where is the starting point. Just for you to orient it for that line. So this being said, you can do now various calculations. So you can use these variables to essentially do AB multiplied by B that will now multiply your entire vector with A. So if you do AB multiplied by B, we basically iteratively. Yes. No?
Like my other boxes on my screen, like updating everything.
Yes, you need to run the line. Just control enter.
Right.
Yeah, it doesn't work. You need to. So you go basically on every line, you go on line 1, you press Control and Enter, you run the first line. And then with every line, you need to do each line individually. Each line needs to be run. Or you select the entire thing with Control and A, and you run the whole thing in one. That's also a possibility. But I probably would not go there. Yes, you were first.
Yeah, but mine doesn't have like the numbers on the side.
Which side?
On the top. Like I have the step, but it doesn't say that.
This here?
Yeah.
You don't have to. We can look at it later. You should have it. Yes. Yes, you need to run every line. You click on the first line, you press Control and Enter at the same time. Then it will run every line and it will do these computations and will pack these objects into your environment. Okay, yeah, we're computing anyways. What do you want to show me? Okay, 7:34, we got our feet wet in R, so we got a little bit of a head start. Play around a bit with it. On Canvas, you have the actual code that will do exactly what we did in Excel for you in R. So if you copy this code into R, into your script, save it as a script, and run it one after another. That's fun exercise. Shows you exactly how to build those frequency tables. And I see your uncurbed enthusiasm for it. Okay, have a nice evening. See you on Monday. Search your share folder and save it there.
And also for this one, I can't believe it. This one's about 0.2 seconds. Also, I don't know why. Did you get 27 now? 37. Okay, on the full one
The
now.
formula is correct.
Okay, so that's for this one. And I just drag it all down. And then for these two, what do you do? Just manually put them in. Okay, and the first three formulas that you found before is for frequency, proportion, and like percentages. Okay, and then these will just be the. Probably harder.
Well, it will get more challenging, but you get more comfortable. It's a steep learning curve. It's a It is statistics. I'm not gonna sugarcoat it. It's challenging, but it's like I'm trying to bring it across and by examples.
Yeah.
Yes.
I was on time today, but before our class on Wednesdays, I have an organic chemistry lab. No, but I was here. No, I was here.
What's your name?
I was here for attendance today,
Oh,
but I know I wasn't here like last week. But in general, if I missed attendance, should I do it end of class?
yes, yes, yes.
Because I didn't last week. But
Like, I don't like this attendance business, but it's what.
No. I just wanted to make sure because this week, because it's supposed to end